Hello everybody, I am a tutor of mathematics and physics, and today I want to show you how to simplify nested radicals. The nested radical is a radical expression that contains another radical expression, so-called the expression with square root. For example, this one, or more complex one. And simplification of nested radical means rewriting it in a form that is not nested. It's called denesting. Let's start with the first example. Look at this. Our goal is to rewrite the expression under the radical as a perfect square. We use the formula for squared difference here, which looks like this. Here we have a negative 2, so let's rewrite the number 4 under the square root here as 2 multiplied by 2. And now it's clear that a is 2 in our case, and b is the square root of 5. Right? So we get the following formula. And actually, we got the perfect square under the square root, because 2 squared plus square root of 5 squared is exactly 9. That means that our radical can be rewritten in the following form. We also know that the square root of a squared is the absolute value of a. The absolute value, that's very important, because the square root of any real number is a positive value. So we obtain here the absolute value of 2 minus square root of 5. As one can see, 2 minus square root of 5 is actually a negative real number, because square root of 5 is greater than 2. But the absolute value of their difference must be positive, so the answer here is square root of 5 minus 2. Actually, it was not so difficult example. So look at another one. Here we have more complicated expression under the radical, and a way of how to rewrite it as a perfect square is not so obvious. But don't worry, there is a universal method to do that. Let's write the formula of squared difference one more time. So the point here is to substitute a negative term of the expression under the square root with 2ab. So the remaining part of the expression is a squared plus b squared. Using such kind of substitution, we easily obtain the following system of equations. The solving of this system includes the following steps. First of all, we should divide both sides of the first equation by 2. Both terms a and b are not 0, because their product is not equal to 0. So using the first equation, we can obtain the formula for term b. Now we just substitute it for b in the second equation of the system and simplify the obtained expression. As one can see, this fraction is equal to 0. At the same time, its denominator doesn't equal to 0. That means that its nominator must be equal to 0. So we get the b quadratic equation. It can be solved using the following substitution. T equals to a squared. Using it, we can rewrite our equation in a quadratic form. Its discriminant equals to 900. So the solutions are 48 and 18. We can choose any of them. I've decided to choose the second here. Now go back to our substitution, and using it we obtain the value of a, 3 times square root of 2, and minus 3 times square root of 2. And again, we can choose any of these numbers. And of course, I choose a positive. And finally, we should calculate term b. Using the first equation of our system, we obtain b equals to 4 times square root of 3. So the initial expression under the radical can be rewritten in the perfect square form. It looks like this. As we already know, it equals to the absolute value of the expression inside the brackets. So finally, the answer would be the following, and the nesting of nested radical is completed. And that's all for today. Thank you for watching and goodbye.